In this video, I want to show you how to graph a system of inequalities. Now, remember when we had equalities, that is, lines that had equal signs in them, solving a system of equations just meant finding where the two lines intersected. When we're looking at inequalities, we aren't just graphing a line, but we're graphing a line and shading. So when we solve systems of inequalities, we're going to graph, and we're going to see where the shading overlaps. Where the shading overlaps is our solution to the system of inequalities. So let's look at one system. Let's say that we were asked to graph the system y is less than 2x minus 3 and y is greater than or equal to 1/2 x minus 2. So these are two different lines. We're going to graph them one at a time. We're going to shade them, and then we're going to see where that shading overlaps. Notice that both of these lines are already in the form y, and then a greater than or less than, or greater than or equal to, or less than or equal to, and then ax plus b on the other side, right? I'm just going to write an equal sign here because that's how we typically see this. But both of these are in that form, with y by itself and ax plus b on the other side. If they weren't, we would have to rearrange them so that they would be. If you don't know how to do that, look at the previous video where I go through an example of that. In this case, let's just start graphing. So the first line that we're going to graph is this one here. The y is less than 2x minus 3. So our starting point is -3, so we can put a dot there. And our slope is 2. Remember, 2, if we write it as a fraction, is the same thing as 2 over 1. So our rise is 2, and our run is 1. So we'll go up 2 and to the right 1 from our starting point. So from our starting point of -3, we go up 2 and over 1. Now, we have to think about whether we're using a solid line or a dotted line. So for this first case, it's less than. So that means that we're using a dotted line. And as long as we're thinking about this inequality, let's think about whether we're shading above it or below it. Because it's less than, we're shading below. If that's unclear to you, I'd really recommend you going back and looking at the first video on graphing inequalities, because there I go through how to decide whether you're using a dotted line or a solid line, and whether you're shading above or below. For now, though, let's put in this line. Let's make it a dotted line because that's what we want. I think that'll be good. And now we can graph our dotted line. Okay. So it's kind of going through those 2 points. Not super accurate, but you get the idea that it's going through this point, and it's dotted. So now let's think about our shading for this line. We're shading below. So again, if we look at the y-axis, here's above the line, here's below the line. So we're shading below the line. You can use arrows if you want to. You can shade it if you want to. Really, whatever is going to make the most sense to you. Now let's take a look at our second inequality, this inequality here. Y is greater than or equal to 1/2 x minus 2. Our starting point is -2, and then our slope is 1 over 2, so we go up 1 and over 2. Greater than or equal to means that we're using a solid line because it has this equal sign underneath, and greater than means we're shading above the line. So let's get that line in there, and then let's do some shading. So we need to go through this point and this point. So there's our second line, and we need to shade above that. Let's do that in green. So we're shading above this line, which means we're going above it. So we're going up. So we can see, to find the overlapping shading area, if we look down here, right? It's all red down here. There's no shading in this little section. Up here, it's all green. But in this little slice right here, we have our red arrows pointing down and our green arrows pointing up. So where that shading overlaps is right in this area here. Maybe I'll color that in pink. So we're looking kind of up here, because above this line, we wouldn't have any red shading. Below this line, we wouldn't have any green shading. So we want where it's both. So that means we're looking at this area that I'm coloring in pink. What that means practically is that any point in that area is a solution where it makes both of these true at the same time. So every point in here is a solution to this inequality. Let's look at what I mean. If we take the point 3, 0, that point 3, 0 is clearly in the shaded area, right? So to do a little check, let's take a point in the shaded area. In this case, let's look at 3, 0. And let's see if it makes both of these statements true. So let's look at the first one. Y is less than 2x minus 3. In this case, our x is 3 and our y is 0. So 0 is less than 2 times 3 minus 3. I've just substituted in my y and my x. And now I'll see if I get something that's true. So 0 is less than 2 times 3 is 6 minus 3. 0 is less than 6 minus 3 is 3. And that is true. 0 is less than 3. So that point that's in the shaded area, where it's all overlapping, makes that statement true. Let's double check it with our second inequality. Y is greater than or equal to 1/2 x minus 2. And let's use that same point just to make sure that it makes both of the statements true at the same time. We'll substitute in 0 for y, and we'll substitute in 3 for x. It's a 1/2 there. That 2 is a little funny. Minus 2. So 0 is greater than or equal to 1/2 times 3 is 1.5 minus 2. You can leave it as a fraction if you want to. 0 is greater than or equal to 1.5 minus 2 is a negative 0.5. And 0 is bigger than negative 0.5. So that's true as well. So we see that this point in the shaded area where that shading overlaps makes both of these statements true at the same time. And that's true with any point that's in this shaded area. So when we're talking about the solutions for the inequality, we're talking about any point that's in the shaded area, as well as any point that's on a solid line. Points on the dotted line itself don't count. So that's what we mean when we're talking about solving systems of inequalities. I hope that helps.